Let's verify the identity of sine x plus y minus sine x minus y equal to 2 cosine x sine y. We're going to be using the sine sum of difference formulas, which I will write for you now. Expanding the left-hand side, that gives us the sine x cosine y plus cosine x sine y minus the identity where we have sine x cosine y minus cosine x sine y. I get sine x cosine y plus cosine x sine y minus sine x cosine y plus cosine x sine y equals 2 cosine x sine y. With the minus sign, the sine x cosine y's cancel, but then I have two of the other terms that are left, which is cosine x sine y, which verifies the identity. Last thing in this section is we are going to be using the reduction formula to get this down to a single term. For some angle alpha with sides A and B and hypotenuse K, then the cosine of alpha was equal to A over K, the sine of alpha was equal to B over K, and then K was equal to the square root of A squared plus B squared. And this was for the expression A sine x plus B cosine x. And so here we see that with the expression negative 4 sine x plus 3 cosine x, our A is negative 4 and our B is 3. And so then K is found by taking the square root of negative 4 squared plus 3 squared, it's a Pythagorean triple. That's going to be 16 plus 9, or the square root of 25, which is 5. So our K value is 5. Our A value is negative 4, and our B value is 3. Sine is positive in the first and second quadrants, and cosine is negative in the second and third quadrants. So for those both to be true, that the sine is positive and the cosine is negative, it has to be in the second quadrant. And in this case, we know that the hypotenuse is 5, the opposite is 3, and the adjacent is negative 4 because of cosine. So here's our triangle. And so now we want to write our expression together. We then know that we have sine 5x plus something, alpha. We don't know what alpha is though. And so we can use the inverse to find the angle, but remember the angle has to be in the second quadrant. And so when you do the inverse, make sure first of all that your calculator is in degrees. When you do the arc sine in your calculator, you get 36.87 degrees, which is a first quadrant angle. When you do the arc cosine, you get 143.1 degrees, which is a second quadrant angle. If you took 180 minus 36.87, you would get 143.1. So our alpha angle is 143.1 degrees. And that's it for this section.